Here's your last video for Chapter 2, the short videos that are just going over the solutions. Remember, you can watch the full lecture and get more details. So we're going to do logarithmic regression. It's the same thing as linear regression, quadratic regression, exponential regression, but now we have a different shape. So we're going to do logarithmic regression. Something you need to note is in the calculator, we don't literally have logarithmic regression. It's going to be ln for natural log. Same sort of idea. So in this example, the following table shows the total spent in the U.S. on research and development in areas other than defense. So our input is year, 5 to 20, and our spending is anywhere from 25 all the way to 41. And so we're going to do logarithmic. So just like the other ones, we're going to put the data in the calculator, we're going to show the data, we're going to get the line that goes through the data, and we're going to answer some questions. So I went ahead and I put the data in the calculator. So I go to turn the calculator on. I do want to point out that we always want to start with a clean calculator. So if you go to y equals, make sure there's nothing in y1, nothing in y2, the plots are unhighlighted. And then we're going to go to our calculator, stat, number 1 for edit, and I went ahead and put the data in list 5 and list 6. So you can practice using all the lists. So what I'm going to do all in one shot is get the logarithmic regression, the data, and the line that goes through it. So first of all, I would always recommend that you plan it out. So what I mean is our input is year, output is spending, the lowest is 5, the highest is 20, so notice I went from 0 to 25, just to kind of show that. Spending, the lowest is 24, so maybe start at 20, you can even start at 0 if you like. I'll start at 20, let's say, a little different than the graph here, and go to maybe 45. But plan out your graph first, because it's really important for the window. So I go to the calculator, put the data in. I'm going to go to second, y equals, turn plot 1 on. Make sure I choose scatter plot. X is list 5, second 5. Y is list 6, second 6. Enter. Then I can hit window. Remember, we're going to go from, what do we say, 0 to 25. Maybe counting by 5s. And then for spending, maybe go from y minimum of 20 to 45, maybe also going by 5s. And I adjusted the window, turned the data on, so when I hit graph, you should see those dots. Okay? Now to get the line that goes through the data, we're going to do logarithmic regression. Stat to the right for calculate, looking for ln when we do logarithmic. So that's number 9. Enter. Our data is in list 5, second 5, comma, second 6 for list 6. If you have the newer calculator, it asks for list 5, then list 6. You don't need the comma. Again, we have the formula. Y equals, for us, it's spending. A is 2.95, B is 12.46, ln of x. So when I go to y equals, I put in 2.95 plus 12.4571 ln of x, and if I'm correct and did it all correctly, that line should go through the data, which it does. Everything worked out perfectly. Again, practice, 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 but linear, quadratic, exponential, logarithmic, all the same setup and calculator. Okay, a couple questions for this. I can fill in some numbers. So for example, I can fill in these. So if I go to the table, if I want to find out a certain year has what value, spending, so I can plug in 5.5, enter, 10.5, enter, 14.5, enter, 21, enter, 25, enter. So if I want to have the year and want to know the spending, that's the way to do it. But let's say I want it the other way. Let's say what year will have a spending of, let's say, 38. Well, if I have spending, I have to go to y equals, and y2, put 38, graph. It will draw a line for 38. There's my estimate based on the data, where they intersect. Second trace, 5 for intersect, enter, enter, enter. And I can say spending is predicted to reach 38 at year 16.67. Okay? And then the last thing we're going to learn in Chapter 2 is we did linear, exponential, quadratic, logarithmic, and now the fifth one is logistic. Logistic is interesting because it starts out low, goes high, and flattens out. It kind of looks like an exponential that turns into a logarithmic. And it has kind of a weird formula. We're not going to spend too much time on the formula. We'll let the calculator do that. This is like an extra one, but I do want to say the number up top is where it levels off. The number up top of the formula is where it levels off. So for example, 1 is what the n would be. It's where it levels off. So we'll do an example. In 2001, there was a growing belief that among analysts that the number of internet users in the United States would reach a plateau, and as the number of U.S. households connected to the internet, remember there's a leveling off, as a function of t. Now we're going to put this data in our calculator. I'm going to use list 1 and list 2, and we're going to do the same exact thing. Data, line that goes through it, but be very careful because you can see it looks a little weird. So I'm going to go ahead and put the data in the calculator. This time I'm going to do list 1 and list 2, but let's start with a clean calculator. Go to y equals, clear y1, clear y2, go up to plot 1, hit enter. So make sure it's a clean calculator. Go to stat, edit. I'm going to use list 1 and 2 this time. The fastest way to clear it is to go up to list 1, clear, enter, don't hit delete. Up to list 2, clear, enter, and I'm going to put the data in. Okay, so I put the data in the calculator, like I said, list 1 and list 2. Double, triple check your numbers, make sure everything's correct. But I always recommend sketching it out first. Your input is time, your output is household, so we're going to go from like 0 to 10, maybe counting by ones. It goes from 28 to 70, so maybe 20 to 80. However you decide to go, sketch it out first, understand the problem first. Then I'm going to go to second, y equals, go into plot 1, turn it on, choose scatter plot. This time x is in list 1, second 1, y is list 2, second 2. Go to window. We're going to go from 0 to 10, counting by ones, maybe 20 to 80, counting by tens, and hit graph. So there's our dots, and when we do the line correctly, it should go through the data. So to do that, stat, calculate. This time we're looking for logistic. Logistic all the way down to letter B. Letter B. Logistic, enter. In this calculator, second 1, comma, second 2. Yours, you may put list 1, enter list 2. And then you notice it takes a little bit for this one. It's doing a lot of work. And I would write it down. So it gives you the formula, and it tells you what the letters are, but make sure you write it down. So when it comes up, it's going to give you that it levels off. Remember that top number is where it levels off is 79.32. So C is 79.32 divided by 1 plus A, 2.21. E, there's that E we talked about, raised to the negative B, 0.326x. So write it down first. Then when I go to y equals, I'm going to type it in carefully. 79.32 divided by parenthesis 1 plus 2.21 e second ln. It gives me the parenthesis, if not I put it, negative 0.33x, close parenthesis, close parenthesis. Remember, if you open it, close it, open it, close it. If I did it all correctly, hit graph, the line should go through the data. And then we're going to answer a couple questions. We're going to find out what happens, when will it reach 70, and we're going to plug a couple numbers in, so I'll make some up just for practice. Let's say I want to predict what happens at 6.5. I can go to second graph, type in what happens at time 6.5. That's our estimate, 63. Or I can type in 2.5, whatever one you want, if we have the input, the time. Or if I want to find out when will it reach 70, because remember it levels off at 79.32, I would go to Y2, type in 70, enter. There's my 70. I'm going to find out where they cross. Second trace. Looking for intersect 5, enter, enter, enter. We're estimating it will happen around 8.51 time. Okay, that concludes chapter 2.